Hello everybody, Namaste and welcome to my channel Civil Laces. Here I am with another video on building analysis by ETABS. In the previous videos we talked about the local axis and global axis and moment 33, moment 22, shear 33 and shear 22. If you haven't watched our previous videos, you really should. In this video we will talk more about analysis and design. Before moving on to the analysis and design, let's talk about the diaphragm. This picture shows the floor masses that are lumped at a point. When earthquake load or any lateral load comes into attack, it acts on this point. So the main thing here is when the lateral load comes, our floor system should act as a point and these should move together. That is, there should not be any relative displacement between any points. So diaphragm assigns the floor system to a point and makes the floor system to act in an integrated manner. ETABS provides you two types of diaphragms. One is a rigid diaphragm and another is semi-rigid diaphragm. A rigid diaphragm considers the infinite plane stiffness while semi-rigid diaphragm considers the actual plane stiffness. So if you assign every floor as a rigid diaphragm, it acts in an integrated manner completely and it reduces your computation time in ETABS. Define the diaphragm and then assign them. For defining the diaphragm, go to define and go to the diaphragms. We don't need to assign the diaphragm to the ground floor because it is already fixed on the ground and every units on it move together. So we need to assign the diaphragms to the floor level above the ground floor, that is to this first floor, second floor, third floor, fourth floor and this roof cover. That is, we need to assign 1, 2, 3, 4 and 5 diaphragms. Click on add new diaphragm and you simply name it D2 and it is rigid, so it's okay. Click on again add new diaphragm, D3 okay, D5 okay. So click OK. So before let's check about what this D1 diaphragm is, whether it is a rigid diaphragm or semi-rigid diaphragm. Click on D1 and then click on modify or show diaphragm. So it is rigid. Click on OK. So we define the diaphragm. So let's first assign the particular diaphragm to each floor. So here I am working on one window, thus I am dividing the window. For that, click on this icon, Windows list, and click on plus add new window. So this is a default 3D window and this 3D window is what we are working at. So click on plan and click any floor plan, apply and OK. We already defined the diaphragm. Now we are going to assign the diaphragm to the floor. For assigning the diaphragm, go to this assign tab. Column basically provides the stiffness to the floor, so column should not be assigned as a diaphragm. For assigning the diaphragm, I need to select this whole floor like this. So if I select this floor like this, then column will also be selected. So let's not do this. At first we have to select all the columns and hide them, and then we have to select the floor. So for selecting all the columns, you can go to the select tab and then select, and then to the properties, and then this is the column is a frame section, so click on the frame section. Our column is column 300 by 300, so click on column 300 by 300 and click select. If you do so, then all the columns are selected. If you just select a column and work in all storage platform, then only that column will be selected. To go through that way, you have to select every columns in a story. So for a faster way of selecting a whole column or any frame section, you need to go to the select tab and then to the material, and then to the frame properties or frame sections and then column 300 by 300 and then click select. You can see that the column 300 by 300 are selected in this 3D tab. So you just need to close it and do right click on any window, and you can see here hide selected objects. So click the hide selected objects. We already selected the column, and if I click into the hide selected objects, it will hide the column from the floor levels. You don't need to worry about this. It doesn't delete any column, but it just hide the selected objects. So the columns are hidden now in the floor plan. Let's assign the diaphragm to the floor. You need to select this floor in this way. It is selected, and go to the assign tab, go to the cell, and then to the diaphragm. Here it is. So let's assign this diaphragm as D1. Apply. Move to the second floor. Again select this whole floor and assign this second floor as a D2 diaphragm. Apply. You can see that all these diaphragms are converted into this point, which might be the center of stiffness to the floor. Go to third floor, select this floor, assign D3 diaphragm to this floor. Go to the roof floor now. Again select this whole floor, assign this floor as a D4 diaphragm. Apply, and then go to the roof cover. We also need to assign this roof cover as a diaphragm. Click this floor and then to this D5. Apply, and finally OK. Thus the diaphragms are assigned now. So we are ready for running the analysis. Here in this video I am going for the design, but I cannot directly jump into the design before running the analysis. So we first run the analysis, and before running the analysis we have to check the model whether there is any warning messages or not. So for checking the model, go to this analyze tab and click on check model. Click on select all and then click OK. So it gives some warning message here. Horizontal rigid diaphragm connection formed between joints at different elevations. Please check. So it displays a warning message, and we did some mistake while assigning the diaphragm. I realized that mistake. The mistake was while selecting the floor for assigning the diaphragm, we select this whole floor, and during the selection of this whole floor, this slab is also selected, but this slab is not on this floor. This is the landing slab which is below this floor. So the same diaphragm cannot be assigned to the two different elevations. Thus I am going to delete the landing slab diaphragm, because landing slab contains only one cell. We don't need to assign any diaphragm for the landing slab. Click on OK. We need to delete the diaphragms of landing slab. So click on all storage platform here and click the landing slab here from 3D tab. Make sure the only landing slab is selected. So I select the landing slab, and all the landing slabs of building model have been selected. I need to delete this diaphragm of landing slab, and for that go to the assign tab and then to the cell and then to the diaphragms. So this is small screen pops up, and here are the diaphragms from D1 to D5, and here is another option called none. So we simply need to apply none to this landing slab. Apply and OK. Diaphragms are assigned to only the floor levels. You can see that there is a shift in the center of stiffness positions. And D5. Now we are perfect for running the analysis. So again go to the analyze tab and then click on check model to see whether the errors have been fixed or not. Click on select all and then OK. A small screen pops up saying that model has been checked and no warning messages were generated. So we are perfect for the analysis. I already said that we did some analysis in the previous video, so I'm concerning for the design, and I cannot jump to the design without doing the analysis. For just that sake, I click on the run analysis. Now ETABS is running the analysis. So it shows the deflected shape. You can do start animation. You can click on this icon to see the deflection due to the various types of the loads that you have defined. For example, I'm going to see the displacement due to main wall load. You can see here displacement due to main wall load. Click on start animation. Stop the animations. If you want to see the displacement due to other load, you can click here again, and it shows that displacement due to the partition wall load. You can start animation. Stop the animations. Again, if you want to see the displacement due to various load cases, you can click here. This is displacement due to the live load 3 plus. You can do the start animations. The main purpose of analyzing the displacement due to through animation is to see whether there have been any unreal displacement or unreal movement or not. You have to see some results of analysis and reconfirm whether you can go for the design or not. To see some analysis results, go to the display tab and then to this show table. Click on show table. So here comes the model analysis and design. We haven't done design yet, but we have done analysis. So click on this plus sign to expand the tree. At first, we need to see some results of analysis. Click on this plus sign of results to expand the tree, and then click on reactions. We are first seeing the reactions. Click on the base reaction and OK. So it shows the reactions of various loads due to dead load, due to live load, due to main wall load, due to partition wall load, parapet wall load. You can access this data by right click here and export to the Excel. For now, we will just see here the data. The main thing you should look for here is the reaction due to earthquake load. Here is the load case combo EQX. EQX is the earthquake load in the X directions, and the reaction due to earthquake load is minus 161.65 kilonewton. And the reaction due to earthquake load Y is minus 161.6567 kilonewton. It confirms that mass source and static earthquake load have been applied to the model. So we are good to go. Click on this sign and again to the display tab and show table. We just see some base reactions and it is okay. Click on minus signs to shrink the tree. Now click on this model results plus sign to expand the tree. Now we need to see the model participating mass ratios. Click on the model participating mass ratios and OK. During the define operations in previous videos, I have told you that the mode cases or the total number of the modes that have been assigned to the building is 12. So it does the operation up to 12th number of modes. And modes is simply nothing but frequency of vibrations that building vibrates. Up to 12 number of modes, you can see that some of the participating mass ratios up to 12 number of the modes, the sum of the participating mass ratios is about 95.64 percentage, and some of the in y direction it is 93.75 percentage. Simply this value should be greater than 90%. Now I am going to tell something about mass participating ratios in building. So you just need to confirm here that some of the mass participating ratios is above the 90%, that is 95.64% and 93.75%. We are again good to go for design. Regarding the mass participation in the building, you need to know certain facts. Basement of the building doesn't participate in the vibration at lower modes due to the low frequency and higher time period, because basement is very much fixed around the surrounding soil and the fixed offset doesn't easily vibrate. The superstructures have greater flexibility and they take part in the vibrations where the time of period of the vibration is very large. The time period of vibration is very large on the lower modes because it has very small frequency. Thus, to participate the basement or the lower masses in mass participation, time period of the vibration should be very small, and that happens at higher modes. If your mass participation ratio doesn't come over the 90%, you should increase the number of modes in the define tab. We check the base reactions for earthquake load and mass participation ratio in model analysis. Now we can go for the design. So to go for the design tab, click on this design tab and then to the concrete frame design. So click on concrete frame design, and before going on any design tab, you first need to select your preferences. So click on the view revise preference. We are going to design our building with design code Indian standard 4562 2000. If you want to change your design code to any other standards, you can have various code set here. So, but basically we are doing the design by using IS code, IS 456 2000. So click on here. You don't need to do anything for other values. So click on OK. Again go to the design tab and then to the concrete frame design. You have to give some certain rules for rebar selection for columns and for beams. So click on rebar selection rules for the columns. And it has differentiated into the two types, that is designed for non-seismic design for non-seismic requirements and design for seismic requirements. The smallest bar size for longitudinal directions for the column is we are good for the 16 and largest bar size 28. It is the general practice. And for the tie bar, smallest bar size could be 8 mm and largest bar size should be 10 mm. So you don't put the value of largest bar size above 12 because those have very less ductile property, and if the bars have very less ductile property, you cannot bend them properly. Tie bars should be bent in a proper manner. Minimum spacing 50 mm, maximum spacing 150 mm. Or you can specify the minimum spacing of 100 mm because it doesn't make so much of differences, but you just need to do this. So click on OK. Again go to the design tab and then to the concrete frame design and rebar selection rules for beams. So here also for the seismic requirement and non-seismic requirement and seismic requirement, smallest bar size for the top bar you can choose 12 to largest bar size 16 mm and the preferred bar size 16 mm. Similarly bottom bars 12, largest 16 and preferred 16 mm. You can do the same thing here. For stirrup bars 8 mm and largest bar size of 10 mm, minimum spacing 75, maximum 150 or 300. It is as per the code, so it doesn't make any difference. Click on OK. Again go to the design tab and then concrete frame design. We have already fixed some rebar selection rules for columns in the beams. Now we will check the select design combinations. So click on select design combinations. This screen pops up. So here the list of combinations are those combinations which you have defined in define tab. That we have defined the ETABS default code combination from UDCON 1 to UDCON 14 and envelope. And design combinations are those combinations which the ETABS is designing which the ETABS is going to design the reinforcement according to this force generated. If you basically select these all the combinations and click here, it will go on to the list of combinations. So envelope and UDCON 1 to UDCON 14 are the combinations that we have defined in define tabs. So what forces are going to give in the design combinations? We have to select those now. Click on UDCON 1 to UDCON 14 and then click on this icon to give them into the design combinations. Now UDCON 1 to UDCON 14 forces are going for the design combinations. We don't select this envelope option because the main function of the envelope is to give the maximum values of UDCON 1 to UDCON 14. In the design combination sections, ETABS by default choose the maximum value from the given combination. So there is no point of giving this envelope option to the design combinations. It is used in analysis. Click on OK. Again click on design and then concrete frame design. We have completed all the tasks before the design. So click on design and then to the concrete frame design. Now we can start design. So I click on start design. Now ETABS is designing the reinforcement. My screen was active here while designing. So if I active here and start design, it will show the reinforcement and design in this tab. You can see that ETABS is designing the reinforcement on every beams and columns. The more number of stories you have in your building, the more time it takes for design. But we have very less number of stories because it is a residential building. ETABS design it very quickly. You can zoom in to see the reinforcement value. These are the reinforcement value. For example, if we see the design value for any beam, you can go to that beam by zooming it and then right click on it. You can see this small screen. You can click on envelope option or summary option. So this is the section of the beam and it gives you all the information about that. It's on the level roof and element B11. It has the unique name of 42. Section ID we have beam 200 by 200 and the maximum combination that gives the maximum value of the load is UDCON 8. Similarly, you can see all the different properties, the factored moment, factored torsion, factored shear force, factored axial force. You can also see the values of shear reinforcement. So if you click on flexural details, it will give the required rebar informations. For top bar, the total cross-section area should be 225 mm square. For bottom bar, 112 mm square. And for specific minimum requirement for the rebar should be this. So you can see the required information from this design tab. Select any column, for example this, and right click on it. You can click on envelope to see the rough details. For example, this has given you all the information that you need. Design code parameters, longitudinal reinforcement required. For example, 720 mm square is the longitudinal reinforcement required. And the rebar percentage is 0.8 percentage. And all the controlling combinations, that is UDCON 14 is the controlling combinations for design force. Design, it has given the design PU for top and the bottom, design moment, and various information about the shear reinforcement. And so in this way you can see the design informations. Previous drawing files got deleted permanently, so I am doing from this file. The important step in design is to verify the all members passed. That is, we have to verify that previously defined frame section is sufficient to withstand the stresses and forces so that there is no any failures. For verifying the all members passed, you can go to the design tab and then to the concrete frame design, and you can see here verify all members passed option. You click on verify all members passed. So your message appears which says that one concrete frames failed the design check. Do you want to select them? So now we have three options to correct this error. Either we have to increase the section size, or increase the grade of concrete, or increase the grade of steel. The best and easiest way is to increase the section size. So click yes. You can see on the plan view this beam is failing, so we have to increase the size of this beam. Since we are on to the design stage, the model is locked now. Click on this key icon, which you can use it to unlock the model if it is locked. Unlocking will delete all your result analysis. So click OK. Now the model is unlocked. This is the frame section which is failing. Only the first floor beam is failing, so we have to, it is already selected. Now we have to assign a bigger section to this. Go to assign tab and then to the frame and then section property. This might be the beam 230 and 300, so this time I'm assigning it beam 400 by 250. Or to confirm it, I can check the size of the beam and right click on it. It is the beam size of 400 by 250. Now we have to give bigger size of the beam. It is still selected. Go to the assign tab and then to the frame and section property. Click on beam 400 by 250 and then modify show definitions. Or you can modify any beam. So if I want to modify beam 230 by 300, you click on beam 230 by 300 and then click on modify show property. The previous beam which is failing was 250 by 400. So this time I am defining beam 400 by 400. Give the depth of beam is 400 and click OK and then click OK. So assign this beam as a beam 400 by 400. Apply and OK. You can see that this beam is now beam 400 by 400. So again now you have to run the analysis, and for running the analysis you can do it directly from this icon, run analysis. You can access it by typing F5 on the keyboard. Click on run analysis. So analysis is completed. Now you can go directly for the design. To assess the design in shortcut, you can go to this icon and click here. Now ETABS is going to design. The reinforcement have been designed. I'm just here to confirm the all members are passed or not. So go to the design tab and then to the concrete frame design and click on verify all members passed. You can see this small screen which says that all concrete frames passed the design check. Congratulations, you have completed the design of your building. On another video, we will make some detailing and report preparation. This much for the today's video. Thank you very much for watching the video. Please like, share and subscribe our channel to learn more ETABS videos and other engineering software videos. Thank you.